We're back, and we're on number E. Believe it or not, we only have 4 more left to do. 4 or 5. 1, 2, 3, 4, 5. And then we are done with SQL. And we can move on to another topic after this. So let's see. Let's finish this up, and then I'll preview number 4. Assignment number 4 you're going to do on your own. It's a paper you're going to write, but you have 2 weeks to write it in. So you actually will have some homework after today. But feel lucky. You don't have a midterm. Like the class tomorrow has one. You guys don't actually have one, which is really good. Instead, I'm going to torture you with SQL. So there we go. All right, so number E reads, retrieve the names of all employees who worked on every project. All right, after these other ones we've been doing, this one's pretty simple. So we know we're going to do select from where, so I'm going to go ahead and type that in. Perhaps I should make this a little bit bigger for the blind, including myself. So let's see, what are we going to do? First name, maybe? Last name, maybe? That sounds good to me. Where's it going to come from? Probably it's going to come from employee. Yeah, okay, employee. Sold. And F name, comma, L name. What am I going to do here? Retrieve the names of all employees who worked on every project. Every project. So we're going to select the first name, the last name from employee, where the social security number, do we have that in there? Let's see. Yep, social security number is in, remember those subqueries we did? And the subqueries, we said in a group, not in a group, intercept a group. Actually, I was just talking to somebody at the break about the subqueries. This subquery we're going to do is going to be a select social security number from work on. So what are we going to do here? Let me just write it and I'll tell you what we're going to do here. Select ESSN from, I think that was in works on. Those are all the people. Okay, so the subquery says select employee social security number from work on. That's going to give us the group of all of the social security numbers of all the people who worked on projects. And then on the outer query, we're going to select the first name and the last name from employee, where the social security number is in this group of social security numbers of all the people who worked on projects. So this is an example of one of the subqueries, well, the query in the query that we did in the bars, where we had potential friends. So you query all of the people who frequent a bar, and then you make sure that all these people in this group are not, I can't remember the person's name, but not this other person who was trying to find potential friends. So if you remember that query, this one's very similar to that. So this is going to come out with a set of social security numbers. So if we did this one, let's just do it this way. I'm going to copy this. If I run this outer query, if I run the inner query, select social security number from work on, what do I get? I get social security number, employee social security number. I get 111222333 because I put all 3 of them in there. So I get 1, 2, 3 in my query results. So if I do this, then if I come back up here and put, this is the inner query. Now I'm going to select first name and last name from employee, where and this is really employee. If we wanted to be more specific, we could say employee.social security number is in. If we do that, then we're going to get Frank Wong, Bob Smith, and Larry Smith. Well, they gave him the last name, Larry. So we have the 3, because we had those 3 social security numbers. We had 111222333. But what you see, though, is that we're actually selecting first name and last name from employee. where the employee social security number is in this group of social security numbers that we got from querying the works on table. So we found all the social security numbers that were in the work on table. We put them into a set and we said, give us where social security number in employee is in this group. And believe it or not, that's the query. Or is it the query? Is it the query? Is it the whole thing? It can't be that easy, can it? Retrieve the names of all employees who work on every project. Every project. We can add another where, actually. We can say where the project number, where the project number is in the project number from projects. Would it actually work? Let's see. Where project number. Actually, employee doesn't have it. Works on now has it. No, we don't leave that out. But can it be that easy? Retrieve the names of all employees who work on every project. I think that actually could be. That could actually be the query. I'm pretty sure that's the query it wanted. First name and last name. Retrieve the names of all employees who worked on every project. Yeah, we're getting every project because we're selecting star. Are we selecting star? Well, we're selecting employee social security number. Yeah, we're getting all the projects here. All the social security numbers, and we're getting all of the employees who are in this here. Yeah, you could do that too. Where, let me do yours here. Where employee social security number equals, oh, you have to put it up here then, work sign. See what happens when we do this one here. We want all three of them to come out of here. And we got all three of them. Yeah, that works too. Someone's got to, Someone's got to, Do we have an what's your Which one did you want to see? Yeah. That's what I'm trying to say, though. There's a couple of different ways of doing this. You could also say where the project number is in select project number from project. And then you can do, instead of doing the work on, you can do projects. Because the project table, let's see, let me actually take a look here. I'm going to save this one for a second. Or just copy it just in case I need to put it back. And project numbers, no, we're going to get it from the works on. We're going to definitely get it from the works on table. And we're going to get the social security. Well, yeah, she's got a good point there. That this query is probably the better query. Unless you wanted to use an in. I think that's our final result. I don't think we need to make it any more complicated than that. If you wanted to use the in, you could use the in. That would actually work. But what we're doing is, it's kind of very similar to what we did in the previous couple of queries. We've got the first name and the last name, and the employee and the works on table. Technically, this query would probably run slower than the one we had up there with the in. Because we're doing two tables in one query versus one without a join. But I don't think it's going to notice a difference, really. All right, moving right along. Number F says retrieve the names of all employees who do not work on any projects. Well, that would be the not in. That one would actually work. So all the employees who are not in that other group, well, we're going to come up with nothing because all the employees I put in here are working as part of the other one. So if that were the case, I could go back to the query I had before. The query I had before looked like this, actually. F except for the not in. And then it was select SSN from works on. So we have not in instead of in. It's going to give us the people who are not in here. So if I added an employee, I'm going to get nothing. Nothing is going to come out of this one. So instead, I'm going to add an employee who's not working on anything. So here's an employee. Oh, let me make this smaller so I can navigate this one here. I got Frank, Bob, and Larry. Let's put another one in here. I'm going to put Curly in here. Curly, he's not going to be working on anything. What's Curly's last name? Larry, Curly, and Mo. Stooges? The Three Stooges? Stooge is Curly Stooges, whatever his name is. Social Security number 444-444-4444. Birth date 666. Ooh, 66666. Ooh, he's an unlucky guy. 1, 2, 3, 4. Address 222 Unlucky Lane. He's a male. His salary, he only makes $5,000 a year. Supervisor. 1. Who's that other supervisor we had? 11-111-1111. Franklin's supervisor for everybody. Department. He works in department number 1. Oops. Duplicate key for 1. Oh. Alright. I get it. 2. I have to put another department. I put the department number. Yeah. Let me go back here. Let me fix this department. Well, I'll just make another department number. The way that I have the departments, it's because I put that key in there to make it unique. I can't have more than one employee working in one department. Well, I'm going to get around it because I could take the constraint off. Let's take the constraint off. We're working with department. If I come into and just remove the constraint, that'll solve the problem. Or I can remove the unique. So I'm going to go into designer. Where's my department? Department location. This is the problem right here. Where's my button to delete? Delete pages now. How did you get yours to delete? Ah, there we go. I have to click on it. Let's see if that fixes the problem, actually. Department for employee. So my employee department number. I'm going to lose my box. I'm going to lose my drop-down box. But the way that I did this is that only one employee can work in one department with the unique. So let's see. Let me go back here and insert another person in here. And now I'm going to put Curly back in. Curly. Stooges. Address. 1, 2, 3, Unlucky Lane. Now let's see, I'm going to put a department number 5. But now it... Okay, let's put 8 in here then. Alright, so department 8 doesn't exist. So technically, for Curly, there's no such thing as department number 8. Which... I thought I removed it. I think, well, no, you know what it is? I removed the constraint, but I didn't remove the unique value here. In order for me to do that, I'd have to drop this department number and re-add it if I wanted to remove it completely. So, let's just leave it alone. So go back to my query that I had there before. So now I'm going to select first name, last name from employee where employee social security number is not in. Select social security number from works on. I should get Curly coming out because Curly isn't working on any of those projects. He's decide. Ooh, department number. Wait a minute now. Well, he should still come out. Let's see. He does not come out. Let's see. Why doesn't he? Let's see. What did we do wrong here? Employee social security number is not in. Select social security number from works on. Oh. Let's see. There's Curly. Okay, good. Easy mistake. That's why when I actually do my own tables, I'm following this example, I actually name them the same thing. So SSN is the same thing in all of the different tables. So I don't know, it's ESSN in this one and not SSN. So I don't know. Anyway, we'll see how the not in works instead of the in. Now can you do that one? Yeah, I could do the same thing probably. What did we do before where the social security number equals social? So it doesn't equal. So if we did that, this is the first way of doing it. The other way is to put a comma here and go works on. And then take this one here and say where it's not equal to workson.essn. And we're still going to get Curly coming out of here. Oh, actually we got a bunch of stuff here. Distinct. First name, last name from employee, comma, works on, where employee social security number doesn't equal works on social security number. No, there's something flawed with that. What did we do before? We're equaled. Let's see. Just do a group by F name. Well, I think the in this particular case is going to give us the not in. This is not equal to though. So, do we not have isn't Bob and Franklin and Larry, aren't they in that works on social security number? I think they are actually. We could do this. Where employee dot social security number equals works on dot ESSN and doesn't equal. Oh, that's an interesting logic. No, that's gonna it can't be both. It can't be both. This is actually not gonna work. So we do this one. This one works though. I think we have to use the not in. The not in is going to give us what we want. This is going to give us. This is not going to give us Curly because Curly doesn't equal. I know we could do this, or employee dot first name equals Curly. I know, this is not the way of doing it. It's never going to be and or at the same time either. Alright, you guys didn't see, that was a joke actually. Let's just take that out of there. Okay. The not in, I think the not in is the only way I can make it work. Not equals to this one. Let's just make sure the not equals. If the not equals is not working. And oh, what about this one here? What about this one? Where employee dot first name is equal to curly. That would mean I'd actually spell it correctly. I have no idea how I spelled it. Oh, I spelled it like that. There we go. But that's not the query that was asked for. The not in is the only way I think I can probably do that query. The inequality is not working for me. So the not in is probably a safer bet on that one. All right, I think we killed that one. Let's see. G, retrieve the average salary for all female employees. Oh, I can do this one. I can do this one, no problem. Select from where employee is the table. And what are we going to get? Average salary. Salary. There we go. Where gender? No, I think it's sex is equal to F. We don't have any females in this query. I'm going to change it to M because it's null. We don't have any females in this. No, we have no female employees. I know I put a female dependent in there, but I made all the employees male. So I'm going to change this to M just for the sake of running the query. If we put it to M, we're going to get the average, and the average salary is $72.25. I hate to wonder what we put in for the salaries, but let's just see. Oh, you know why? Because the salary in employee, I didn't put in as a number, I put it in as a text. So let's browse this for a second here. And let me edit this one here. I'm going to put a number in here, like 28. I don't know if this is actually going to work because it's still a text field. 56. I might have to change the type of the field. 10. It's going to turn it into ASCII equivalents. You know what? I have to change. Let me put it into a number instead. Let's go back here. Actually, let me change the structure. Well, let me change the field. Hold on 1 second. I almost have one more left. I still have to change the. I still have to change one more here. Otherwise, I'm going to get an error when I put it into a number. I'll just make this one 5. Now I'm going to change the structure of the table, make the salary a number, integer, there we go. Take this out, save it. So now the salary is a number, so now I should get a better average. So if I run the query now, still not going to get anything for females because I didn't put any females in there. But I should definitely get a number coming out of here. And I do. It's 24.75. I think I put like an average like hourly salary, not an annual. All right. Let's see. Number H. Find the names and addresses of all employees who worked on at least one project located in Houston, but whose department was not located in Houston. All right, so let me go back to the locations here. I need to put Houston in here. So let's put another one in here. Insert. Department number 5. I don't have number 5 in here. I'm going to put number 5 in Houston. Let's see if I can spell Houston. Houston. H-O-U-S-T-O-N. So now I have a location in Houston. And I need to find the names and addresses of all employees who worked on at least one project located in Houston, which would be project 5, but whose department was not located in, do we have a location for employees? I believe I do, actually. but my address I didn't put in correctly. Let's skip this one because we didn't put the address in correctly. Because we'd have to go where department number is equal to department number from project. Oh no, project's got location. Department locations, department number, location, project location. Let's see, wait a minute, project location. Project location. Well, we could run this. Let's run this then. I might have to put some data in a few minutes, but let's just see. Select from where. Let's see. What am I going to select from? From employee, comma, project and department locations. Project locations, department locations, And what are we going to get? First name, last name, and address. So employee, first name, last name, address. Employee dot first name, employee dot last name, employee dot address from employer. This is the where clause. Department number is equal to project department number. How about where project dot location is equal to Houston? Project dot location. P location is equal to Houston. I don't think I have anything in here though. And department location. Department locations dot D location equals null. Does not equal Houston. Or equals null would actually work. I don't think I have any. Let's see what happens with this. Nothing. That's because I don't have any departments. I don't have any department locations. Don't equal project.p location is equal to human. I don't have any projects that are equal to Houston. I put the project location file, or department locations I put in Houston, but I didn't put any projects. That would be the query if I actually put, back to here, let's just do it. Edit, copy, department locations. Oh, I have Houston. Projects. All the projects P locations are in Sophia. Let's change one of these. Well, then actually they should all come up. Let's see. Let me try something else here. That should have worked. Make this a little bit bigger so I can see it. Yeah, Houston. Oops. You're right. I don't think that's going to fix things, but we'll see. No, I didn't fix it. But yeah, thank you for the spelling mistake. Okay, I'm going to do this now. Houston. So let's just put in something else here. I'm going to say employee number, department number, employee D number is equal to project D number. Let's join the two. I want to join employee with project table and then project table with department locations. And employee D number equals department location dot D number. Let's try this out. No, I think it's because we don't have data. Let's see. We're selecting employee first name and employee last name and the employee address from employee, project, and department locations, where employee D number is equal to project D number. Employee D number is equal to project number. Employee D number is equal to department locations D number. Project.p location is Houston. And department.d location doesn't equal Houston. That should work. Why is it not working? Let's do it this way here. We want to get the ones in Houston. Nothing. Let's try a simpler query. What do you see that? What line are we on? Over here. Employee. Let's see what that brings us. I don't think we have a P location. We have a location. We have employee. Well, yeah, we don't have a location in here. That's the problem. Let's do this. I just want to see something here. I'm going to select an employee first name, last name. We could use department. Hold on 1 second. Now I'm like really select project dot name where project location equals to Houston. You have an error. Oh, from. Hello. From. I got too carried away with this. From project. I just want to see the location come up actually. There's no results? Did I misspell Houston? This query is not working. I think it's because my data is wrong. Project. There's no Houston in here. So I just want to get this query to work first. Let me just add one in here. Hold on 1 second. Project name, Houston project. Project number 9. Location, Houston. Department number 10. Houston project. Houston project. Okay, very good, very good. So we were going to select employee. What do we want to do? We want to do employee. Which one are we on? We're on number H. Employee first name, employee last name. So we have employee address from employee and project and department locations. Because we now we want to find the department locations. Now it's the where clause. Employee department number is project department number because we want to find the employees that are working in the departments. So I'm going to leave this where down here. I'm going to add a new where. Employee D number equals project D number, and employee D number, E number, employee D number. Okay, we're project. Wait a minute, we're projects. Let's do this one here. Project location is equal to Houston, and where project location equals Houston. Location number. Yeah, well, let's just do that one. Employee dot D number equals location dot D number. Department location. And this query is going to be the death of me. And project P location equals Houston. Let's just try this one out here. I think I'm missing data. This is where I'm going with this. We have to get it out of all three of these tables and where all of the department numbers match. We're trying to get the ones, so apparently my department locations here. Actually, let me copy this one here. I'm determined to make this work. Let's see. Edit copy. I think my problem right now is the department locations. I have Houston for number 5, but we're connecting the D numbers. So let me make another department 8. Well, let's see which. Hold on one second. Let me go to the departments here. Let's go to the employees for a second. Project. I have the Houston project, which is project number 9, and it's department number 10. So departments. I don't have a 10. All right, I'm going to chalk this up to a really hard query to create because my data is not in here correctly. But theoretically, if I had department numbers that matched with project numbers and location numbers, so if I had department locations with department numbers that were also in the employee table that were also in the project table, and I could match up all the, because I'm really doing an equality in all the department numbers. Then I could test if all the department numbers actually matched, which is my problem, they're not matching. Then I could possibly see if the location was equal to Houston, and also that the locations weren't null or weren't empty, or were not equal to. So this query we can kind of just leave as is, I think, actually, and just kind of take it as is and not worry about it. In fact, you could scratch this one off the list if you don't like it, like I don't like it. So anyway, but that, if I had data there correctly, I think that would actually give me the correct one. Or did it say not in Houston? Located in Houston, but whose department was not located in Houston. So I'd have to add that line I had before that said, and the employee location is not Houston. So if I wanted to fix it, I'd come down here and say, and employee. Well, we don't have the address in the employee either, so we'd have to put the location in the address field of the employee correctly. So I'm gonna leave this one alone. It's not worth it. So the last one, number I, says to list the names of all department managers who have no dependents. Those would be the ones. This is actually not a bad query. The last one's not bad. So this one you can leave blank if you're churning it in. Just cross it off the list. I don't like H. Because I have to like make too much. H actually works, but I'm not getting any query results because I have to populate my tables correctly, and I didn't. So we'll just leave that one alone. the names, list the last names of all department managers who have no dependents. Well, here's our departments. And our department manager social security number. You know what? I'm going to cancel this one out too because I have to like make managers social security numbers match employee social security numbers. So let's change the query around a little bit. And let's just say employees. Because my data is not going to match. Because I didn't put manager social security numbers. Yeah, let's just make it so it's employees. Let's list the last names of all employees who don't have dependents. I think that's a better one. So if that's the case, that's an easy one. Actually, we gave everybody a dependent. That's not going to be easy for our data, but let's say ones that have dependents. How's that? We're going to select from where. I gave everybody a dependent. Remember, I did little Bill, little Bob, and little Franklin, and little everything else. So I'm not going to have anyone come out. So I'm going to do the opposite. I'm going to change the query. You can put down the results here if you want. And use this one for I. So we're going to select from, let's go employees, comma, dependents, dependent, and we're going to list all the pairs. So I'm going to select employee dot first names, comma, dependent dot dependent name, from employee, comma, dependent, where employee dot, oh god, maybe I should start out with dependent first, where dependent dot social security number, very good, is equal to employee dot social security number. Let's see if that one works. It means I would actually have had to put the social security numbers incorrect, and I did not. Oh, no, I did. Here it is. Okay. So Franklin's got little Franklin, Bob's got little Bob, and Larry's got Larry. Because remember, we had another query where the name of the dependent had to match the name of the employee. So that's where we got Larry and Larry from earlier. So I changed the query. If you're turning this in, if you want to turn this in revised with the new query, you can use it this way. I know. I changed the question. I could say it doesn't equal, but the problem is they all have dependents. I gave them all dependents. My data's messed up. I don't have any that don't have dependents. I'd have to actually go put one in there that has a dependent. This is going to be, yeah, I changed the question. So it says list all the employees who have dependents instead of all the managers who don't have dependents. Because you can just say, you can just, well, you have to find the manager's social security number, match it with the employee's social security number. If they match, which they don't, which is why I don't want to do it. And then cross that with all of the dependents and their social security numbers. I can do an in, actually. I could query the table. I could actually do a not in. So I would do, let me write it underneath actually. Select employee dot first name. Let's just do the first name from, oops, select would have to be spelled correctly. Select employee first name from employee, where I'll do an in because that's what we have. In select where employee dot social security number is in this grouping, and it's going to be select ESSN, ESSN, I think it is, from, what is it, dependents. does dependent have an ESSN? Or does it have SSN? ESSN, that is correct, but I don't think it's capital. Let's just do it this way. Actually, all I have to do is this, dependent dot ESSN, there we go, from dependents. Actually, both of these two queries will run. Well, they run side by side. Oops, let's take this one out. Franklin, Bob, and Larry. So this actually, so if I were to do it, I would actually do a not in, and then I would get all the employees who don't have dependents. So they all have dependents, so I'm going to come up with nothing. Oh, a curly. Oh, curly, that's right. Remember I added curly. So curly doesn't have any dependents, you're right. Okay, this works then. All right, there we go. That's a better one. There's like half a dozen different ways to write that one. But I think we've exhausted this assignment. No? I'm exhausted from this assignment. We're done with this assignment. Let's look at the next assignment, unless we have questions about this one. Yep. All right. So you do not have to turn the database in, by the way. All you have to do is turn in the queries, cut and paste it from here, and just stick them in there. You don't do them all, don't worry about it, just submit it. If you've submitted it already from last weekend with the first one in there, that's fine. You can leave it alone as well. I'm just looking for, kind of like, and I'll do attendance at the end, but I'm just looking to see if you actually like made an effort to follow along with it. So on that note, let's go take a look then at the next assignment, which is number 4. That one was number 3. So now we have number 4. Lucky number 4. This is a paper that you're going to write, and the paper that you're going to write is going to be due on August 22nd. So if I take a look at the calendar here, I thought I had the calendar opened. It's in one of these. Here it is here. August 22nd, which is the next time we're going to meet. So don't rush out the door yet here. I want to go over this assignment. Let's see. So August 22nd is when we're going to meet. And this assignment is going to be due. We are not doing this assignment in class. This is an assignment you have to do on your own. So it's a research paper. I'm going to go over it in a few minutes. So we'll see how that works. This one was number 3. So number 5 is a database normalization example that we'll do in class. We'll do number 5 in class on the 22nd. It won't be due till the 29th. I took out number 6. I removed number 6, and instead I'm going to replace it with in-class exercise number 1 and number 2. But we may or may not do that. I have to play things by ear and see how next week works. Because I really want to do is more application development next week. So the next week, 2 weeks from now, the next time I see you, we're not going to do any more SQL, thank God. We're not going to do especially as much queries as we did today. Instead, what we're going to do is focus on connecting to the database. And we're going to have an introduction to HTML and PHP as a scripting language, because PHP is used a lot in web development to connect to a database. So I want to show you how to write simple, and I'll put together some simple scripts. We'll leave your database that we did for assignment number 3, leave it alone, and we'll use that as a basis. So write down that computer number. So we'll use that as a basis so that we have something to query and have something to run. If we don't do that, what I'll do is I'll just write the SQL create table script, and we'll just cut and paste and stick it in. Because what I'd like to do is look at web interfaces to databases and the front end of database applications, running reports, creating forms to input data, running queries from a website. We have the environment already set up. It's an XAMPP. And then we'll also cover database normalization. Pretty easy. We already know it. We just need to finalize a few things on that. We'll also do that next time I see you in 2 weeks. So between now and 2 weeks, this is when you have an assignment, because we don't have really a midterm in this class. So instead, you're going to do this here. It's called Business Database Systems Project Assignment number 4. You're going to write a paper, and the paper is going to be 4 to 5 pages and like double spaced. That means really just 2 pages, single spaced. All right, what are you going to do? You're going to compare and contrast generations of databases. How are you going to do that? You're going to need to do some research. This is a graduate level class. This is a master's program. Research is part of the components, and writing skills is another part of the component that you're supposed to get out of the learning outcome from this particular experience. So what you're going to do, we don't have a textbook for this course. Not a problem, actually, because there's really no good textbook out there that's going to cover everything about business database systems. But you're going to use the library. You're going to use the internet. You're going to use your resources. You're going to write an academic paper that's written by you. That's not plagiarized off of the internet, that you don't cut and paste from other sources and assemble together. So most of the points on here is going to be credit for your own writing effort and practice. And I know that English is probably a second language for practically everybody these days. So I'm not going to be so critical, and this is not an English class. I'm not going to be so critical on your use of punctuation and spelling and stuff. But, most word processors have spell checkers and grammar checkers and stuff. However, you're not going to be docked points for imperfections in the writing. I would rather see you make an attempt to write legibly and to write in an academic style versus trying to give me something you think is supposed to look like it's supposed to look, if that makes any sense. So I have a lot of students that don't want to write it themselves. They want to cut and paste it and borrow stuff because they don't have confidence in their writing, and they don't want to practice it, and they think it looks stupid or something, or they don't want to do it because they're lazy and they just don't want to write it. So use this as a learning opportunity to practice and focus on your writing. In the business world, writing is actually kind of very important as well as speaking, but writing is definitely, especially in the electronic day, definitely a skill you want to take to heart. So what are you going to do? You're going to compare and contrast generations of databases. The theme of this paper is on generations of databases. Hierarchical, network, relational, and object-oriented databases. We're in the middle. I've been talking about relational database concepts. Entity relationship diagrams are relational. MySQL is a relational database. We've been creating tables, and we've been relating them with keys back and forth, and today we've practiced a lot of that, actually. So you know what a relational database is. The other two you're probably not going to know very much about. Hierarchical was the predecessor to this. A hierarchical database, just so you know, is sort of like a file system. In fact, most network systems originally started out as hierarchical databases. So you have a file server, file server, file server. You put them together in a file system, and it's basically file-based. That was one of the first database systems, actually. If you Google, or you just go to a library and look at hierarchical or networked, I put a dash here. You can talk about hierarchical or network or both together. You're going to compare it to relational, and then you're going to compare that to object-oriented databases, which is really the wave of the future. Well, it is the future. It's not really the present right now. Most industry is working with relational right now. So you're going to explore the differences between these three, and you're going to compare and contrast, and you can focus on anything you want. You can have your own comparison contrast criteria. You don't want to fill the paper up with recycled graphs and charts. You want to make sure that if you're going to put in a lot of graphical stuff, like here's a picture of the relational database and it takes up a page and a half, it doesn't replace the word count of the paper. I have had students do this where page 1's got 2 charts on it, page 2's got 2 charts, and they have 4 pages, but it's all pictures and charts with a couple of sentences in there. Nah, I would rather see less of the charts. However, a chart is good. Or a table is good if you want to put together a comparison, contrast. If you do put something together, cite the source if you're going to borrow it from a source. But I would prefer that you created the chart yourself, especially if it's a comparison chart. You know, so you can maybe go relational, hierarchical, and object-oriented, and then maybe compare it with speed or support for application development or support for something. I don't know. You can come up with your own criteria. I'm not going to tell you what the criteria are. So your research paper should be about 4 to 5 pages in length, double-spaced, and you can provide graphic illustrations to demonstrate the concepts if you want. You don't have to. You don't have to write them yourselves either, except for you want to make sure you reference everything you borrow. The idea is to investigate and explore and to learn the different types of database implementations and the different types of designs that are out there. Make sure you include the following. Provide a complete overview. You want to provide an overview or a summary of hierarchical, relational, and object-oriented databases. What are the various similarities and differences between these systems? What makes the database design unique or different from each other? Compare and contrast. Provide references, citations for all of the information you found and used. Use this as an opportunity to explore APA or MLA or Little Brown Book or anything that you're familiar with from a writing style perspective. You can put it in any format that you want. But provide a reference citation. What do I mean by a reference citation? Let me put one on the bottom here. Barbara said on 8/8 that you should please provide reference citations for all of the words you take that are not yours. And then I go like this and I go Hecker 2015. So this is a quote, a direct quote, because I have it in quotation marks. And I'm doing this because I'm trying to make sure that there's absolutely no doubt in anyone's mind what I'm talking about. That's a direct quote. If this was a published book or something, or I don't know, this video I guess could be used as that, I would put my last name, and then I would have a reference list somewhere. Then you know, reference list. So references. You know, maybe on a separate page, and in here it would say Hecker, last name, comma, first name, date. If I were doing APA as an example, 2015. Title, how to write clearly. And it was by, publisher was, I don't know, Absence Press, located in Palo Alto, California. You get the gist, hopefully, of what I'm talking about. And this, you can underline this. If you are not familiar with how to write reference citations, then you can do this. You can go to APA, reference citations. Do you really want this one here? Well, no, I think you want apa.org. But American Psychological Association was the APA stands for. This is a school of psychology. The school actually follows the APA style guide. We're a computer science program. We don't necessarily have to follow it, but if you're looking for one, this is actually quite common. And you might end up taking a psychology course, and you might end up having to write a paper in the APA format, especially at this school. You're probably going to end up having to do this eventually for another class. And if that is the case, then there's probably a good investment. If you go to apa.org, it'll take you here, but you don't have to go here to find how to do the reference citation. For example, I could Google how to reference a book. How about a website in APA? And I can get to, oh, this is the one I want. It's the Purdue OWL site. This is actually not a bad website because it shows you examples. This is an online periodical. Here's another couple of examples. And this is really what the reference citations look like. you're just basically taking the author's name, the date of the publication, the location, the publisher, stuff like that, and you're documenting what it looks like. So if you're looking for a good one, the Online Writing Lab, OWL, it's from Purdue, is not a bad resource because in some cases, well, there's a couple of, it's called the editor machine and stuff. In fact, Microsoft Word will do this for you. You just insert the reference and it'll tell you, like it prompts you with a little dialog box and you just fill it in with the information and it creates it for you. So bottom line, use whatever resources you can in terms of help. If you're not familiar, you don't like this writing format, you don't like APA, use something else. I don't really care what you use. What you want to do, however, is make sure you're doing something of an academic quality that is referencing. It's not a cut and paste thing, especially at one of these days you're probably going to end up wanting to publish something if you haven't done it already in another school or something. If you're going to publish something in a journal or something, they're going to want you to demonstrate academic writing skills. So this is not a bad way of practicing. So what do we want? We want to compare and contrast. You want to make sure that you have the similarities and differences between them. You want to make sure that the database, so what you're going to describe what's unique about them, what's different about them, that you double space your paper, that you provide reference citations for all of the information you have found. You include a bibliography page at the end, or you can call it references. And you write the paper in your own words. Do not plagiarize and do not consult others. This is an individual, not a group assignment. Questions about the paper. So really, 4 pages is the minimum. Double space is 2 pages. If you can't write 2 pages, actually you're probably going to end up with more. If you're the kind of student who likes to write a lot and you want to include a lot of pictures and stuff, go for it. There's no maximum page length. The minimum is 4 pages. The maximum is how many you want, but don't make it your life project. It's due in a couple weeks, so don't make it like your entire life project. And it was due the night of the 22nd, so you can turn it in via the Canvas system anytime you want, even next time we meet. After, if you want me to look at it and say, hey, is this what you want? I can say, yes, it is. And then you can upload it after that if you want. Or you can upload it anytime. Questions about assignment number 4? No. I think the other class just let out because I've seen him in the hallway. So it's like already 10 after, and I think we've had a long day, and it's hot in here, so let's go. So if we don't have any questions, we're going to end, and I'm going to stop this video.